And again, let's take a look how it looks. I'm going to go slightly faster here because it's going to be, again, the same flow. We are still in non-ML examples, webinars, how to estimate ML performance of deployed models. And now we're going to click on classification. And going to classification, again, let's hope it doesn't all fail. First, we're going to import our data. We're going to do the same thing. The only difference is now we're trying to classify our model. So I'm going to use light gradient boosting machine with classification. I'm going to load data. This time, we're trying to predict whether electricity in Wales, these are, by the way, all real life data sets that you can find on openml.org, which is a very nice repository of open data sets, in my opinion, much nicer than Kaggle. So check it out at some point. We're going to load the data and we're trying to see what's the prediction. It's either up or down. We get some numerical columns because it's already has been pre-processed. So the data set already is this kind of pre-processed form. We're going to process our data. So just we want to get 0 ones in our class. So if it's B up, it's 1. That's it. And we're going to drop our day because we're lazy and we don't want to deal with features that are not numerical. And we obviously need to drop our class to not cheat. Then we're going to split the data, same story as before. We're going to train the model, again, same story as before. We're going to score and predict. So we need to make separately the scores. So we use the predict probabilities. It features heavily in the algorithm, so we definitely need to have them. And we're going to just make the actual predictions using implicit threshold of 0.5, as you normally have in most of the algorithms. Then we'll prepare the data for an email, exactly the same thing as before. We take our features from the test set, we add the predictions, we add the ground truth, and we also add our model scores. So again, just to mention here, these probabilities don't need to be calibrated. The algorithm itself calibrates the probabilities. And again, these are model scores over here. I need to push it afterwards. So we have this data and we're gonna initialize and feed CBPE. And like I mentioned, we need our model score name, so Wojtek proba column, which is just called Wojtek proba. We need our predictions, which is just Wojtek. We need to know what's our target, and we need to know the metrics that we're trying to estimate here. And just choose something that's like not all based on confusion matrix directly. I'm going to use ROC AUC and I'm going to use F1. And imagine this time that the story is slightly different. It's not that you're trying to predict something far in the future, but you deploy the model, you kind of forgot about it, and it just keeps on running. Nobody's really looking at it. So we're going to estimate the performance. We're going to, by the way, that's another thing I wanted to show you here. You can also just do 2 data frame at the end of your results. Let's say that you only want to look at our analysis. So you can filter the results for analysis, turn it into data frame, and then display it. And you get very nice data frame that you can play around with manually if you want. And for every chunk of data, you will get the index keys. Let's say we don't have timestamps. If you have timestamps, you can also use timestamps here. And you will get all the information about the performance, the thresholds, the confidence band. So we'll use sampling error for that, and the actual value. Now let's see how this looks like. And imagine that this time you actually did not monitor the results, and we see that everything is going fine. For ROC AUC, there is maybe a slight dip at the end, but actually on our test data set, the model was not performing as well as we would like it, but we're still happy with it. And F1 actually increased very significantly after deployment. And that kind of tells a different story in the sense that you still need to monitor the predictions because you might be missing out on certain opportunity on upside. Imagine that you're very conservative with your credits because you knew that the model is not that correct and there is significant risk in giving credit to somebody or buying electricity, as in that case, on trading all electricity. Your bet size was very small when you're trading electricity because you knew your model is not very good. And it has ROC AUC that's significantly above 0.5, but it's not that great, but maybe you evaluate it by F1. And we see here, most probably because of the change in class balance, F1 just shoots up extremely high. And that means you might actually want to change how you deal with that downstream. And if you were not estimating the performance, you wouldn't be able to find out. And again, just to validate that this thing actually makes sense, we're going to follow the same flow. And we see that ROC AUC slightly goes up, and so does F1. Here, ROC AUC, we didn't actually estimate it very well in the beginning, but then we find this peak and we find this drop. And with F1, we basically get it perfectly. There is peak, there is drop, there is peak, there is drop. It's almost perfect estimation when it comes to F1. When it comes to ROC AUC, made a mistake here, but it's still quite useful. And you've seen that the algorithm can be potentially useful not only when the model fails and not only when the model degrades, but if anything unusual happens, such as the performance improving.